Welcome to the Museum of Curiosity. My name is Bill Bailey. I'll be playing the theme tune tonight. And each week I'll be using a different chord. And this one is the unexpected major chord.
Hello, my name's John Lloyd and I am Professor of Curiosity at the University of Buckingham. The Museum of Curiosity is unique in that it is the only museum in the world so far that is not limited by theme or genre, the only qualification for an exhibit being that it must excite curiosity. Here's Bill Bailey with the details.
Yes. Well, we haven't got much in it at the moment. I'll be honest, it's not the most easy museum to curate. It's quite tricky. We've got the Heisenberg wing. We're not quite sure what's in that or where it is. The Alfred Nobel Early Explosives wing, the interactive section. The gift shop's pretty empty at the moment. We've got the conceptual jigsaw and the virtual key rings to the doors of perception, but they're not shifting.
So, talking about Heisenberg, did you see that thing in the paper the other day? 2 American cosmologists, because of Heisenberg's uncertainty principle,
yes,
have said that by gazing at the dark matter of the universe, we are actually hastening its demise.
Really?
Isn't that strange? A bit of music there, I think.
Oh.
Thank you.
Bit of mystery, bit of dark matter music. I've never actually accompanied dark matter on the piano. Actually, no, I did a gig with Christopher Berg. No. No, I've never said that.
Thank you. Well, anyway, each week we invite 3 distinguished members of the Museum's Steering Committee to propose glaring omissions to our catalogue, and today we are delighted to have with us Dr. Philip Ball, Professor Marcus de Sotoy, and Dr. Jonathan Miller. Marcus de Sotoy is a fellow of Wadham College, Oxford, where he's a professor of mathematics, the author of a mesmerising book on prime numbers. His latest book, Finding Moonshine, about the search for symmetry, is just out. He's written numerous important academic articles, including one on the number 42 and another one on 23. So, 42, Marcus, what's
42,
going
that's
on there?
a classic number,
Exactly, and I'm interested why it was chosen for the Hitchhiker's Guide. First sight, it looks a totally boring number.
It is the funniest of the 2-figure numbers, as Douglas Adams used to say.
Yeah, very curious.
So
but actually, there's another writer who was obsessed with it, which is Lewis Carroll, actually.
Really?
You find it all over. The Hunting of the Snark, the beaver arrives with 42 boxes, and Rule 42 in Alice in the Looking Glass. He was quite obsessed with it.
Do you have any favourite numbers?
Yes, actually, my favourite number is 17.
Right. 17, what's good about that?
It's the number I play for in my football team, so it has a lot of significance for me. But it's also a prime number, so that's... in fact, the whole of my football team plays in prime numbers. So we were doing incredibly badly in a lot of non-primes, so I decided that we needed to do something about it. We were bottom of our league, and when we changed our kit and we all play in primes from 2, 3, 5, all the way up to 43, that season we got promoted. So I think there is some magic to these numbers.
Amazing. What is a prime number?
It's a number which is only divisible by itself and 1. And they're really like the atoms of arithmetic. So they're the indivisible numbers, the numbers you can't pull apart. So 15 is not prime because it's 3 times 5. But 17, you can't write that as 2 numbers multiplied together.
23 is also a prime number to do with football, isn't it?
Yeah, that's right. You see, everyone had this... why did Beckham choose the number 23? That was the big question several years ago. And everyone had their own different theory. The Michael Jordan theory, sell a lot of football shirts in America because they all think it's a basketball shirt. And Julius Caesar was stabbed 23 times in the back. So others said, very bad idea for Beckham to be putting 23 on his back. But as soon as I saw that, being a math nerd, I said, it's a really interesting number because it's another prime number.
Yeah.
So
there's a lot of science involved in the art of football. In the World Cup, Mark Lawrenson, the commentator, was talking about the way that he said what they're trying to do. He said they're trying to get the ball into the corridor of uncertainty.
Heisenberg again, you see. Yes.
I just love the idea in training. Right, come on, lads, into the corridor of uncertainty. Well, we've got it in the shoebox of doubt. Is that any good?
I would say most people think maths, if you're not a mathematician, wasn't a particularly mysterious thing.
It's deeply mysterious. I mean, for example, these prime numbers, we don't understand how nature chose these numbers. It's the biggest mystery in mathematics. In fact, there's $1 million in offer to anybody who really understands these numbers.
It's a nice round number, isn't it? $1 million. Why did he choose that particular number?
Yes, yeah, I know. He should have chosen a prime 1,000,001 or something. Right?
Is that a prime?
Well, I'm not that obsessive about... I'm actually... believe it or not.
Yeah, you're sounding a little bit like you are.
Well, look, we're coming back to numbers in a moment, but we must move on to Philip Ball. Philip Ball's a chemist and a physicist and a consultant editor for the magazine Nature, the author of many award-winning books on subjects as diverse as colour, pattern, molecules, water and Renaissance magic. In 2004, the Financial Times named him Guru of the Week. What did you get named Guru of the Week for?
For a book that was looking at human behaviour, looking at whether there are rules that govern human behaviour, whether there are universals to it.
And did you come up with any conclusions?
Well, I think if we watched people filing into this room and filing out again, there'd be patterns in there that no one here has ordained, but that would recur with any crowd pretty much anywhere. And I think you can see throughout society social situations where we do obey particular patterns that are just collective. And it is starting to look as though some of those can be understood in the same way as you can understand the behaviour of just inanimate objects, atoms and molecules, bumping into each other and interacting through simple forces.
You recently wrote an article on magic carpets. What's all that about?
Well, magic carpets are... it turns out that they're feasible. We can make a magic carpet. There's a catch.
For you at home, he's on one now, hovering.
Well, no, the catch is they're very small.
Oh, really? How small?
You could...
Tiny. A mouse could fly on one.
Smaller.
Smaller than an ant.
An ant could do it.
A magical ant. Something like that. So I'm just still intrigued as to how the magic carpet flies.
It has to vibrate. In fact, it has to undulate.
And so what's making it vibrate?
Well, that's the thing.
Ant.
You
the
have
ant's
to,
doing it.
No, the ant is sitting there wishing it would stop. But no, the carpet, it has to be powered in some way. But there are materials that will do this automatically. And if you apply an electric field to them, they'll flex. People have made stuff like this. In fact, they've made little artificial fish that can swim that way. So in principle, you can make these very thin sheets of material that will flex like that. And what happens is that as they flex, if you like, they sort of push up against the air and create a pressure underneath them.
A colleague of mine in Oxford explained how the Indian rope trick could work. I mean, and again, it's to do with vibrating. If you vibrate something very fast, and actually it sort of defies gravity and stands up, and you could go up this thing. In fact, he got his paper put in the Magic Circle. It's the only mathematical paper, I think, in the archives of the Magic Circle.
This is a worry, because I read in the New Scientist, I think, that they think they can do an invisibility cloak like in Harry Potter. Is that possible too?
That's another thing. People have made invisibility shields already. The trouble is you can see them. So, you know, it's a start. But if you saw in microwaves, then you couldn't.
Dr. Jonathan Miller is an art historian, comic actor and writer, medical doctor, film director, opera producer, television presenter, gallery curator, science historian, painter and sculptor and cartoonist. Bill, you have a question for Dr. Miller, I think?
Yes. What do you do in your spare time?
Well, Jonathan, I'd say you're an ideal candidate for suggesting something for the museum, because I think you've got more than your fair share of curiosity. Were you always this curious?
Not when I was very young. I think I became curious when I made the shift at school from classics to biology. I did so very much against the wishes of the headmaster, or the high master, as he was called at my school. He sat at the very end of a long table, lightly pressing his fingers together, and said, "Miller, I understand that you want to make a move to the science side," he said contemptuously, "where people made stinks in test tubes," he said. He said, "But have you ever realized if you want to become a doctor and you abandon classics, if you discover, as you undoubtedly will, a new disease, you'll be unable to name it."
You've done so many things, it's hard to know where to start, but you were saying to me earlier, you only briefly were a comedian, really, only for
Just for a
year
year
or
and
so.
a half, really, not much more than that.
Arthur Koestler wrote a book in which he compared the way that comic minds and great scientists think. Do you think there's anything in that?
No, I know he makes a comparison between the comic and the inventive, and I think that sometimes what happens is that you bring together previously apparently unassociated categories or concepts which make people laugh because they hadn't previously seen that they were related to one another. And I think that certain science actually does suddenly bring together previously unrelated things.
Peter Cook, you knew once quite well. I knew him towards the end of his life pretty well. Now, there's an extraordinary piece of consciousness there because the way that he thought that stuff would come, as it were, out of nowhere. Did you feel that when you spoke to him?
Absolutely. I used to stand in the wings when we were doing Beyond the Fringe, and I gazed with amazement at his inventiveness, because he came up with new things every night. And they always went off at such strange, odd angles.
But there was never any effort involved, was there? You never saw him do any work.
No, it was...
I never saw him even pick up a pencil to write anything down.
No, I mean, he did write things down, but most of the things came absolutely spontaneously out of nowhere. I remember one night he came up with this thing when he was this E.L. Whisty character and saying why he had never become a judge, because he didn't have the Latin to become a judge. And he said that, as opposed to a minor, he said the mining exams are very unrigorous compared to the judging exams. And he said the mining exam, they only ask you one question, he said one night. He said, "Who are you?" And I got 75% on that.
Well, now it's time to put the panel on the spot and ask them what interesting items they propose to place in the museum. Mr. Curator, over to you.
Thank you, Professor. That tells you that the museum is now open for donations. Dr. Miller, perhaps we might start with you. What is your submission to the museum?
I've always been rather struck by these rather peculiar and wonderful pieces of bas-relief sculpture made at the end of the 14th century and into the middle of the 15th century. They're called the Nottingham alabasters. For a long time they were thought to be made in Nottingham, but probably they were made more widely by itinerant craftsmen all over England and then exported in enormous numbers to almost every European country. You can find one in the museum at the Capodimonte in Naples. You can find them, there are about 40 or 50 of them in the Victoria and Albert Museum and in many other museums. And they are representations of the lives of saints and martyrdoms and so forth, but also the most impressive ones are connected with the Passion. And the ones that I've always liked best, and they're often repeated many times and then exported in large numbers, is the representation of the resurrection of Christ. Now, it's very odd that someone like myself, who doesn't believe in any of that stuff, should find himself so moved by these extraordinary Gothic sculptures. And there is Christ stepping delicately out of his coffin, almost as if he's stepping out of the bath. And there's a delicacy about him, as if he's asking the sleeping soldiers for a towel. And there is something about the drowsing figures of these sleeping soldiers around the tomb. And there are many other representations of scenes of the Passion, and I think they are the most extraordinary items. They're carved in alabaster. They once were painted, and the paint has faded and disappeared, and you can just see little tints here and there. But then I have a passion for Gothic sculpture. I think the biggest catastrophe that befell sculpture was the Renaissance. And when you get these rather noble things like Michelangelo's David, which I think is the most vulgar statue I've ever seen in my life, it looks as if he's cruising Goliath. I mean, I always feel it's got this thing, well, who's a big boy?
What happened to these alabasters then?
Well, you find them all over the world, certainly all over Europe. They were exported in large numbers, and you can find repetitions of certain themes. I must have seen 20 or 30 different versions of this particular thing of the resurrection, which vary, but nevertheless there's a sort of thematic center to it. And I suppose that these Nottingham workmen were just doing it. You know, you're doing another resurrection. Yes, I know.
Right.
But,
Yeah. I'm doing Christ in the bath.
But they were exported in very large numbers. And it was almost mass production, except, of course, they didn't have anything which could mechanize mass production. It was all handmade. But they are startling and beautiful objects.
Has mathematics got anything to say about art? Jonathan's saying how beautifully found these things, but you think numbers are beautiful, don't you?
Yes, I think, and I think it's a very guiding principle in doing mathematics is to look for beauty, because that's often where the truth is. I mean, sometimes it can really trick you. I mean, I was working on a conjecture for 10 years about something which I thought was really beautiful until a student came in one day and showed me my conjecture was completely false and the whole thing was very much more messy than I thought it was going to be. So you have to be careful with beauty, I think.
How many of these things do you think we should have in the museum, Jonathan? I mean, more than one, is one sufficient, or do you need a range to really...
I think that it would be better to see, I think, about 10 or 15 of them, because then you get the idiom and the style of them, which is really rather... If you have one of them, I mean, they are very startling, taking one at a time, particularly these resurrection ones. They are rather wonderful.
Philip?
Well, I thought that we might talk about the fact that the Puritans didn't like these and broke lots of them. It seemed to me that would be quite a nice for a room to have the bits of stuff, bits of art that someone hasn't liked and has, for ideological reasons, broken up. We'd have those
stained glass windows
Buddhas and stained glass windows.
Okay.
The hospitals that Thatcher didn't like. Just thought I'd get that in.
Very moving, truthful and interesting cri de coeur for Nottingham alabasters. They're in the museum. Thank you very much.
That indicates an item has been placed in the museum. So, Phil, what is your submission to the Museum of Curiosity?
I'd like to submit a fictitious element. During the 18th century, people used to believe that things burned because they were full of phlogiston. And this is the element I would like in the museum.
Let's get that again.
Phlogiston.
Phlogiston?
Yes, it's from the Greek meaning to set on fire. So their idea was that anything that burned did so because it had plenty of phlogiston in it, and as it burned, it released it. And that was why, for example, you started with a big log of wood and you ended up with a little pile of ashes because all the rest was phlogiston that had come off and entered the air.
Right.
People believed this for 100 years or so until it was finally replaced at the end of the 18th century by the idea of oxygen. I think it's worth remembering phlogiston because, amongst other things, it shows us how science progresses, which isn't quite as orderly as we're often told it is. The standard line now is that phlogiston was a silly idea that was devised by a chap called Georg Ernst Stahl, and that it was replaced by oxygen, which Antoine Lavoisier, the French chemist, came up with, and everyone said, we should have realised this is obvious. It didn't happen like that. It was a very messy business. And in fact, when the relative merits of the two were being debated, there was no obvious reason why you should prefer one over the other. And I think that's often the way in science, that you don't suddenly have an experiment that comes along and disproves the old theory and everyone holds up their hands and says, right, out with that theory and in with the new. Not only because the evidence isn't always clear, but also because scientists are human and they get attached to their theories. And so all the people who had believed for so long in phlogiston continued to believe in it and continued to say, we don't believe in this French nonsense. Even people like Humphrey Davy, who knew a thing or two about burning stuff and combustion, had a belief that Lavoisier's oxygen would just be a fad and we'd see the end of it before long.
There's a few theories, haven't there, that were not accepted at the time. I mean, nuclear energy. Albert Einstein said about it, there is not the slightest indication that nuclear energy will ever be obtainable. It would mean that the atom would have to be shattered at will. So obviously that went on to be disproved, but that was the sort of belief at the time, and it was very hard to shake that off.
It's the name atom. People forget that that's what the word atom means. Right. It means indivisible.
Right.
These were brainy guys, weren't they? They were brainy people. They weren't just freaks or sort of eccentrics.
Well, it is very interesting how very partial they were. You see, here is Lavoisier, who knocks out phlogiston as far as he was concerned, but he's perfectly willing to subscribe to an equally sort of immaterial substance for heat, caloric he called it, as if there was a substance which flowed from hot parts to cold parts, like some sort of invisible water. He subscribed to that, and so did Benjamin Franklin, who thought that electricity was, in fact, a fluid. The notion of a sort of immaterial fluid runs through and actually also is part of the physics of the ether.
But even today, aren't we looking for gravitons and Higgs bosons and things that are supposed to be the lumps that gravity clings to? Is that any different, really?
Mm-hmm. Well, it may not be. We talked about dark matter early on. We haven't a clue what dark matter is. It may turn out that there is no such thing as dark matter, but that we're just seeing the problem in the wrong way. That was what was happening with phlogiston, that it was actually the opposite of oxygen. That it shows that the opposite of a good idea can also be a good idea and can make a lot of sense. I think it's particularly true today of so-called dark energy, which is not the same as dark matter. Most of the universe is this dark stuff. Everything we can see is just a tiny proportion relative to all this stuff. We have no idea what it is. So something serious is missing from our understanding.
Dark matter, yes, it emits no light or heat. It may not even exist. Very much like the soul of Simon Cowell. Does it actually exist then? Did it ever exist?
Phlogiston?
Yes.
No, of course not.
It depends. I mean, what does that mean? Did it exist in the 18th century?
Well, we need to know whether it does or not, otherwise we're not having it in the museum.
I can't have a conceptual entity in there, I'm afraid.
No. The room of conceptual entities is stuck.
Oh, well, we'll have to... Yes, we'll create rooms as we go.
Bill, what room's it in?
The cupboard on the left.
That's phlogiston.
Lastly, Professor de Sotoy, may we have your submission, please?
Well, I'd like to put in a mathematical object called the monster. Now, probably most of the audience think that mathematics is pretty monstrous and scary, but actually there's quite a lot of beauty involved in mathematics. And I think this is one of the most beautiful symmetrical objects that have been discovered by mathematicians. It's actually the last entry in a kind of periodic table of symmetry. Just as molecules can be broken down into atoms like hydrogen and oxygen, we've discovered, well, in fact, a French revolutionary called Galois discovered that symmetries can also be broken down in kind of atomic symmetries. It's amazing, actually. This guy, Galois, died at the age of 20 in a duel over love and politics, but already by the age of 20, he constructed this kind of theory of symmetry. Now, on this periodic table, one of the first entries is actually the rotations of a prime-sided coin. So if I take something like a triangle or a pentagon or a heptagon or any shape with a prime number of sides, then this is one of the atomic symmetries, the first in the periodic table of symmetry. Now, a lot of the examples of these atoms of symmetry fall into lovely patterns, but there are 26, actually, which don't fit into any patterns, and the largest of them all is this thing called the monster. Now, the wonderful thing about the monster is that you can only see it in 196,883 dimensional space. So I felt that it was kind of perfect for a museum which is in the radio world, as it were. It's something that you can't really see. It's something which can only exist in the mathematical mind.
I can't even conceive it in my mind.
So before we go on to wonder how we get yet another invisible, non-existent thing into the museum, 2 out of 3.
I'm intrigued by something that has... How many? It's nearly 200,000 dimensions then. Is there any way of maybe analogous that we could maybe just... You could sort of describe how that might look.
I mean, one of the exciting things is actually, although it's such a weird kind of, we call it a sporadic object because it doesn't fit into any patterns, but actually we find it in nature in some ways because it's helping us to understand the world of fundamental physics. If you've ever been to the grocer's, then you've seen the grocer packs oranges by using sort of a hexagonal figure, the stacks of hexagons. Well, actually, a 24-dimensional grocer, with his 24-dimensional oranges, has an extraordinary way that he can pack those oranges, and the symmetries of those oranges are, in fact, related to this thing called the monster.
Right.
So does that help?
I'm writing down 24-dimensional grocer.
I want you to be
we have them in Stoke Newington.
Yeah. North London. Ooh, North London. We got 24-dimensional grocers. I'm never this close to a mathematician. I don't know many mathematicians, and I'm just going to ask you this question, and the opportunity. The number 3, for me, is very important in comedy. It seems to be the key number.
The rule of 3.
The rule of 3. 3 guys go into a pub. First one goes in, does something. Second one does something very similar. The third one, they're something different. It's brilliant. And that seems to be how comedy has evolved, and that goes back to Greek tragedy. There was 3 acts, and all the parts were performed by 3 actors. So, is there some sort of mathematical reason for comedy? Do you think?
Well, I think this is pretty clear, actually, because you're a three-dimensional comedian, you see, so it comes in a rule of 3. But if you have a 24-dimensional comedian, they probably have a rule of 24. So, their jokes are pretty tedious, because they sort of start off, an Englishman, an Irishman, a Frenchman, a Nigerian, someone from Bolivia, blah, 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 came into the pub.
Came into the pub, and then the barman said, sorry, we're closed.
Yeah, exactly. That's too many of you in here. Out you go. It's kind of interesting that when you go beyond 3, we actually find it harder to notice the difference. If I put 4 pebbles on a table or 5, you start to find it difficult to distinguish between them. But 3 you can see immediately, I think.
Right, see pebbles on the table. Whoa, I'm right there, straight away.
But if you take some 24-dimensional pebbles and then you throw those into...
You've been to the 24-dimensional aggregate store.
Is it unusual for a big number to be so important? Aren't small numbers really the ones mathematicians use mostly?
Well, I think that all numbers have their own particular characteristics. In fact, there's a wonderful story. Ramanujan was an Indian mathematician who came to work here in England when he was spotted by a Cambridge mathematician called G.H. Hardy. He fell very ill, and Hardy went to visit him on his deathbed, and he couldn't think what to talk. Mathematicians were not very good at social chit-chat, so Hardy sat there for a while and said, gosh, I came in a very boring taxi. It had the very boring number 1729. And Ramanujan said, no, Hardy, it's a very interesting number. It's the smallest number which can be written as the sum of 2 cubes in 2 different ways. So you see, every number has its own special properties. I like that story.
It's a great story, isn't it? That's fantastic.
Right, so we need to put that in the museum. Any suggestions for a room?
The room of imaginary beings. This is a thing of the mind. So,
right.
You'll never be able to see it. You might be able to see flickering shadows of it. What's very interesting, though, is that there are mathematicians around who can really play with this object. And I think a little bit like the Nottingham Alabasters, the skill was kind of lost of being able to create these things. And I think that we might find in 100 years' time that the skill to be able to manipulate this object might also disappear because we've moved on to some other things. So I think we might be in an exciting time where we've got minds who can conceive of this snowflake in 196,883 dimensional space.
Yes. Oh, well, it's definitely in. It's got to go in. The 24-dimensional grocery section. That's where it's going.
Right, our audience today are no ordinary members of the public. The audience is, in fact, entirely comprised of friends of the museum. Earlier we asked them what exhibits they'd like to see, and here are a few of them. Thomas Edison's electricity bill. That's quite good for
a good one. I like that.
Yeah, that's a big one.
Here's one. My suggested curiosity is childhood photos of the Invisible Man.
And lastly, I have here the straw that broke the camel's back. Right, well, that's about it for this week. Our heartfelt thanks to our 3 members of our steering committee, Dr. Philip Ball, Professor Marcus de Sotoy, and Dr. Jonathan Miller. And a final thought from you, Mr. Curator.
I'd like to end up with a quotation from Bertrand Russell. Mathematics, rightly viewed, possesses not only truth, but supreme beauty, a beauty cold and austere, like that of a sculpture. Vorderman.
Thank you very much. Goodbye.
Thank you. The Museum of Curiosity was curated by John Lloyd and Bill Bailey, with research by James Harkin, Xander Cancel, and QI. The exhibits were kindly